Sometimes on the ACT, you will be asked to find the greatest common factor between two or more numbers. Other times, you will need to know how to calculate the greatest common factor in order to solve part of a larger problem. In this video, we're going to review greatest common factor, which by definition is the largest factor shared between two or more numbers. We'll start with some easy examples. When you have two numbers, and the larger number is divisible by the smaller number, the greatest common factor is going to be the smaller number. So between 2 and 4, since 4 is divisible by 2, the greatest common factor is just 2. Likewise, with 12 and 48, 12 goes into 48 without a remainder, so the greatest common factor is 12. With 37 and 185, two numbers that we don't really encounter very often, we can do a quick check to see if 185 is divisible by 37. We realize that 185 divided by 37 is 5, so it is divisible by 37. So 37 is the greatest common factor. When the larger number is not divisible by the smaller number, another method that we can use is listing out all of the factors of each of the numbers. So with 8 and 36, we can list out the factors for 8, which are 1 and 8, and 2 and 4. Then for 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 with itself. Then when we compare the factors, we can see that the largest factor shared between them is 4. So the greatest common factor between 8 and 36 is 4. Likewise, with 16 and 38, we can use the same method. So the factors of 16 are 1 and 16, 2 and 8, and 4 with itself. For 38, we have 1 and 38, and 2 and 19. And that's it. So again, comparing the largest factor between the two numbers, we see that it is 2. In our last two examples, we're going to be using a method called prime factorization in order to figure out the greatest common factor. Prime factorization can be, in some instances, a lot quicker than simply listing out all of the factors of the numbers given. Again, time is of the essence on the ACT since you're only given about 1 minute per question on average. Prime factorization is a method of breaking down a number into its prime factors. So let's take 48 and 112. With 48, we can break that down into 2 times 24. Then we can break 24 into 2 times 12. 12 can be broken down into 2 times 6, and 6 can be broken down into 2 times 3. So then we have 2 times 2 times 2 times 2 times 3 will give us 48, and 2 and 3 are the prime numbers. For 112, we can break that down into 2 times 56. 56 can be broken down into 2 times 28. 28 can be broken down into 2 times 14. And 14 can be broken down into 2 times 7. So 2 times 2 times 2 times 2 times 7 equals 112. And 2 and 7 are both prime numbers. So that's the prime factorization of 112. So now what we need to do is find the prime factors for each number and take the greatest number of times that they appear in both numbers and multiply them together. By that I mean, if we look at 48, we have 2 shows up 1, 2, 3, 4 times, and for 112, 2 shows up 1, 2, 3, 4 times. So both 48 and 112 have a prime factor of 2 that shows up 4 times. So what we're going to do is take 2 times 2 times 2 times 2, and that's going to give us 16. So 16 is going to be the greatest common factor between 48 and 112. We're going to use the same method for 50 and 125. So 50 can be broken down into 2 times 25, and 25 can be broken down into 5 times 5. 2, 5, and 5 are all prime numbers, so we're done with the prime factorization of 50. For 125, we have 5 times 25, and then 25 can be broken down into 5 times 5. And again, 5 is a prime number, so we're done with the prime factorization of 125. Now we notice that 50 has 5 showing up 2 times, and 125 has 5 showing up 3 times. However, they only share 5 twice. So we take 5 and multiply it by 5 to get the greatest common factor between 50 and 125. That leaves us with 25.